right, so we are starting our cycle with functions here. Let me turn down the music a little bit here to kind of get us fading into the sunset. Excellent. So we have sound. We're going live. So welcome to the 6th installment of our learning channel with Python going on in flight. Here today we're going to be covering functions. There is a lot to look at and a lot to consider within that realm, right? You would think that in any language functions are nice and but their functions, they kind of ought to be a relatively simple and relatively straightforward concept. It is to many degrees in that way in Python. The deal is, however, function is a first-class citizen, and then there is a certain set of interesting, I would almost want to say, tooling or certain capabilities that come within functions that are of value to discuss and of value to look into, because you would see a fair amount of frameworks leaning in on that capability, and you might not recognize those patterns or existence of those capabilities in libraries you're using unless you're aware of this. So we're gonna jump over to our screen here as we normally do. So again, we're operating in the world of, we have our Python Learning Marathon website that I'm referencing in a link in the channel that this video is being recorded to. So you will find this video on YouTube as well. We are going to be working in Replit, as I've mentioned multiple times before. If you are on this site, again, all you need to do is go and click on this gray link here, and that will spin up Replit with all the code in it, so you'll be able to follow along for this lesson. All right, so let's take a look at Replit and remember our setup, right? So we're running here in, let me see, I'm running in Python here, so I'm going to exit real quick. Sorry. What's happening? I think I might have hit one button too many. So we are, I shouldn't have, let me reload this real quick. I think I've exited the thing I shouldn't have exited. Okay, so we're running here with Python on the right side and with our code on the left side. We're running in Replit. One of the things we want to go to, since we're going to be dealing with functions.py file here, we want to go into that Replit file, and this is where it's going to indicate which Python file Python is going to be executing when we're going to be debugging this. So when we hit run button, it's going to be essentially running this command. So we want to switch to functions.py and hit run on this just to see that it comes up empty, right? So let me see real quick. Okay, so good. So just a reminder, on the right side, we're running in Bash. And so we essentially have kind of, our little Linux window, and when we execute stuff shows up on the right side. Okay, let's jump into our functions. Function is a common construct in multiple languages. It gives you an ability to group code and redistribute, reuse it in your packages, and we'll cover how to construct packages and things like that in Python later. So we're gonna take a look at a function. So the way I approach it here, we're basically going to progressively build up a function with all the elements of it. It's going to be relatively trivial exercise, but it's valuable to kind of stack up layers and understand how these things print out. So we are going to print greetings to you from Python, and as we go along through the steps, I'll basically kind of copy paste from line above and then comment out the prior and then continue on. You'll see how it plays out, nothing major. So we're gonna print here greetings. I apologize, it needs to go into a string literal, so it's gonna be greetings to you from Python, uppercase R, P, Python. So we have that print, run it, write nothing unexpected, greetings to you from Python. So next thing we're gonna do, pull Python out as variable, right? We've done that multiple times. We're going to do this. We're gonna comment this out just so that we have clean print out here. My apologies. Sorry about that. Let's see. Copy this thing here, push it here. So what we're going to do, we're gonna pull Python into that particular literal into a variable, right? So we're gonna cut it from here. We're gonna put in variable like name. I am using an f string annotation here, so I'm going to turn it into an f string to make our life easier. And then we're going to say name equal to Python as a string literal. We're gonna run that, we're gonna get literally the same result, right? So nothing particularly unexpected there. So wrap both lines into a function without a parameter, right? So what we wanna do, we're gonna grab this line here, we're going to copy this, I'm gonna comment it out, gonna go below line 3, I'm gonna paste it, and then I'm going to define a function, right? So that's the first step that we're doing here. So the first thing we're gonna do to define a function, it starts with the keyword def, and then we're gonna call this function greetings. Greeting, just a singular one. Open parenthesis, no parameters going in. Then the end of definition line for function ends with colon. Sorry, I'm getting calls here real quick. Then so we have that going on. So the next thing to put stuff into scope of a function, like we do with if statements and like we do with for loops, right? We basically tab the whole code in. Essentially everything that is at this level or below tabbed in throughout your code is going to belong to that function. So that's kind of an interesting alignment. So this is where you see a value of having functions that do not exceed certain number of lines in code, just because it, tabulation, like with anything else, becomes a bit maddening. But nonetheless, this is how you would put code into a scope of a function. So now that we have that, the coloring got a bit weird here, but let's run this again. Well, so little nuance here, right? As we put this code together, what we're seeing is that currently we do have a function declared, right? But the problem is that we have not called that function. So because the code is wrapped into the function scope, we do not see the execution happening here. So we're going to call declared function in line 5 here. And all we do is just type in the name of the function followed by open close parenthesis, hit a run on this, and the function executes. Right, so I'll just let you guys catch up real quick. And so we have this function here. So the next thing we're looking at is turn variable with value Python into a parameter and pass literal into the function. So let's go ahead and comment out this line here, and I'm going to copy and comment out these lines here, and we're gonna go drop B on line 6. So what we're looking at here, we're looking at essentially moving this variable name into declaration of a function, and we're just gonna do that. We're just gonna put it here. We're going to let's just remove this altogether instead of commenting it out. And then let's make a call to greeting from a line below, and we're gonna pass in Python literal into it, right? And again, we're on this thing, nothing really changes, right? It runs the same thing. So we can see here that we define a function greeting, we pass a parameter into it name, and then when we make a call, we return. We make a call, we pass it Python as a literal into that, and it executes, and produces the same string for us. So this was really kind of just jumping through hoops to build out a structure for it. So use formatting from within, print to create a greeting and return it, print return value. So what we're looking for here is essentially the f string, nothing magical, but we're performing a function within a function. So what I'm trying to do is, instead of printing something inside the function, I'm going to return it. So let's do the following. So one of the interesting things here, right? The one interesting thing to notice is, as with everything else in Python, you are not declaring any return type explicitly to make this work. All you do is you just run your code. But let's get to the actual return type to see what's happening here. So we're gonna do define. Let's comment this out again, just like we've been doing before. We're gonna do define greeting. We're gonna request name to be passed in here. So the only difference is that we are going to take that f string that we had above, and we're going to return it. So what we're gonna do, let's declare a variable inside result, and we're gonna assign it. It is really just to explore mechanics, right? The code itself is kind of silly. So we're gonna do greetings to you from name, right? And then we're going to return result. So we literally explicitly have to state what we're returning. So we could have multiple lines of code, multiple evaluations, and then return a value from that. So next thing we're going to do, we're going to pull in, let's not call it result. Let's go to my favorite variable, donkey lobster. All right, so we're gonna go and we're gonna assign donkey lobster to greeting, and we're gonna pass in Python in there, and then we're going to print donkey lobster. Lowercase, it has to match, otherwise it makes no sense. Again, really super boring output. However, a few things again to mention. So we declare the function, we passed in name into that function, passed a variable, into that function that was called the name. We evaluated, a string into a result. We returned the result. Then when we call the function, we grab the result into a variable, and then we printed that, right? I mean, it's sort of what you would expect from Python, but it's relevant to know that we can, push stuff in and get stuff out. We don't have to deal with types per se. At the same time, we can print type of donkey lobster, and we're gonna find out that it is I can't type, doesn't have a T in it. Let's try this again. Yeah, so it's class string, right? So what have occurred is that a result inside the function has been evaluated to a type string, and then when it got returned, that got assigned into a donkey lobster, which then assumed the value, not the value, the type during evaluation, as well as the value, obviously. So when we print out the type of donkey lobster, we get a string, right? At the same time, if we print type of greeting, we get to see that greeting is class function, right? So as I mentioned, functions are first-class citizens within Python, and so that allows you to do a fair amount of fun things, as you would expect, in languages like JavaScript and alike. So revisit scope, we have touched on it, right? Your indentation matters, and if I so you have all this code indented here, right? So it just evaluates to a function once it runs lines 25 through 27, and then the code on line 29, as it is scoped at the same level as function declaration, it gets to be executed when Python file is ran. Again, kind of appears obvious, but it's kind of interesting as we're gonna play with modules and things like that. What happens in evaluation time, what happens at execution time. There's a lot of interesting interplay that you can do to leverage stuff there. So there is also, this is kind of where the next level starts. So I'll let you guys settle in and just kind of finish typing this up, and then we are doing well on time. So let's take a look at things afterwards. So there are two types of arguments. I spelled it out as parameters, but it's really arguments. Passing argument, positional arguments in. So there would be two types of arguments for Python functions, and they would be positional arguments and keyword arguments. And so this is where kind of the world of Python and the flexibility of function signatures and things of that nature becomes apparent. And there is, there's a lot of freedom in there, as with many languages, and not many languages, as with many dynamically typed languages. But there is also a certain type of, certain level of structure and enforcement in there as well. So let's take a look at positional arguments. So let's define sample args function. So what we're going to do here, we are going to declare this star.args parameter here. It doesn't necessarily make much sense of what it means, but we're going to play with it in a few different ways. So let's do this. So all we're gonna do is just print f colon, it's helping me, args colon, and then just print out args just to see what's happening. Okay, so let's run this. Oh, nothing's gonna happen because we're not calling a function. All right, so what we're going to do next, we're going to do sample args, and we're going to call with, say, 1 abc true. So when we run that, we're going to get something a little bit more meaningful eventually. Or it's going to take a little bit. Come on. All right, finally we're going somewhere. All right, so I'm going to print a divider here, our good old equals times 50, just so that we have a little nice outline. So what it had done, it had printed a tuple of 3 arguments. So we have a notion of positional arguments, essentially arguments that appear in the order we have taken them in. So this gives us flexibility to declare functions with a flexible number of parameters. That also, so there's a fair amount of application for that. The interesting part here is that what we can do, let's go a next step over, and let's go and declare test comma args. So let's do this. We're gonna do print f, and we're gonna say test. Right, so we're gonna print what goes into test and what goes into the rest of positional arguments. So let's run that again. So we have the first positional argument we assign to a fixed variable, and then the remainder of positional arguments we assign at will. Right. So the most kind of common example you would know in other languages is the whole ordeal with ellipses and uh, uh, printf, right? Ellipsis function like printf and things of that nature. So this is how this would be done in Python. There is a next level to it, which is called keyword arguments. You can think of kind of multiple applications for this one. As we go along, and I'll put out a few more things, I'll dive into detail of where this is actually exceptionally useful. So let's take a look at passing in keyword arguments. So I'm going to print another divider. Let's do another times 50, right, to get our outline, and passing keyword arguments. So in this case, we're going to define sample. So they are referred to commonly as kwargs. Again, the args and kwargs do not have to be in the name. This is just a choice of a name that I had here. So let's put in star kwargs, and we're going to take a look at what those come out to be and how to pass those in. So keyword arguments exist specifically to be able to flexibly give specific names to variables that you pass in, so that you don't have to rely on the position of the variable, but you can actually rely on the name of the variable. So let's see what type this comes back and what it looks like. So we're going to print f colon kwargs. Again, also variable name kwargs is a choice. Essentially, when you declare a parameter with double star in it, the expectation is that those are going to be keyword arguments. So it doesn't have to be kwargs. It could be, again, donkey lobster there, but we're just going to keep kwargs as our go-to. So let's print what's happening here. Obviously, if we run, nothing happens, because we did not call that function yet. So what we're going to do, we're going to say sample kwargs, and then we're going to do things a little bit differently. We're going to declare a variable name, so testing, and we're going to set it equal to 1, 2, 3, and then supported, just because I feel like naming things that way, is going to be ABC, right? So now we make that call, let's run it, and let's take a look at what this is. So what this comes out to be is that when you declare variables and you pass them in this fashion, you end up with a dictionary. So kwargs, when they're passed in this fashion and when they're declared in this fashion, they end up being a dictionary. Okay? So where in the world would you end up? Let me see. Sorry, I just wanted to create accessing optional position. Okay, yeah. So we'll take a look. We'll take a look at those examples of where we would be using them a bit later. So I'll definitely cover that. So let's take a look at a capability that Python has as well that is called default values, right? So that kind of goes along the lines of this declaration. So with positional parameters, so another example, right? So you've seen with positional parameters, we have, right, we declared a positional parameter test, and then we followed it by args, and so that became it became our parameter. With kwargs, it's very similar, but a little bit different. So what we're gonna need to do here is we're going to kind of interpolate kwargs and default values. So let's do def. So we're defining another function, other kwargs, just to have a name. And then what we're going to do, we're going to declare a variable. I don't know, this one, and we're going to evaluate. We're going to set it to a default value of, say, empty string, and then we're going to allow more quarks to come in, right? So and then we're going to print. We're going to print our quarks, right? So we're going to do f, lowercase f doesn't terribly matter, open close. We're going to type quarks are going to be quarks, and sorry, missed it. We're going to go here, and then we are going to print this one is going to be this one. I forgot to make it an F string, mandatory. So we declared that, just run it to make sure we have a sanity check. So next thing that we're going to do, we're going to actually call it. So let's call other quarks, and then what we're going to do, we're gonna just pass a number of parameters. We're not gonna pass anything into this one. We're going to pass a bunch of other ones. Bunch equals 1, 2, 3 of equals play. I have no idea what the things are. Bunch of others equal false, right? So let's run that and let's see what comes back. I mistyped something. False needs to have an e at the end. Let's try this again. So here we go. So we have quarks that came in, which is bunch equal to 1, 2, 3 of equals play others equals false, right? However, we did not specify this one. This one did have a default value, so this one printed out as an empty string. Let's do, I don't know, let's put a couple of, let's keep it an empty string because it's kind of a common default. So if we were to make another call, right, I'm just going to copy this call here and put it here, and I'm going to follow at the end intentionally with, I don't even have to follow at the end. I should be able to go in the middle. This one equals see me now. Triple exclamation points. Don't forget to put a comma following this, hit run. So this is what's happening here, right? Parameter that is named parameter, which is this one, because it's a keyword argument, is going off of the actual keyword, which is this one, which is the parameter value, right? So it doesn't have to appear, because it is not a positional argument, it's a keyword argument, it does not have to appear in sequence. It would be ideal if it appears in sequence because it's more readable, right? If you match this signature of the function, but it does not have to be in sequence. And what happened here is that this one got picked up by our function signature and ended up identified as that as see me now value that we set it to be, right? And everyone else got assigned to quarks element. Okay, so I'll let that settle in a little bit, and then we're gonna look at an interesting trap for our default values. Okay, so the next thing we're going to explore here, I'm going through an interesting trap and then a couple of examples of kind of interesting use and what we could do with this. So beware of mutable default values. So mutable default values specifically are dictionary and list and, well, variety of other collections, right? So the problem with them is as follows. What we're going to do, we're going to declare a function called oops, and we are going to set a um, let's go through that, and then I'll go through example of actually mixing positional arguments and keyword arguments as a separate thing. So let's go with this mutable default value function. So we're gonna declare value oops, and we're gonna declare my list in it, and we're gonna say, hey, my list that we're passing in is gonna be defaulted to an empty list. Right, so kind of, normal. If you didn't pass anything, let's start with an empty list and then we'll go from there. And so what we're going to do, we're going to do a bad thing internally here. We're going to say my list dot append. We're going to append the value to it, and then we're going to print. Let's do f my list, and then we're going to print my list in square brackets, in brackets, and leave it at that. Let's just run it, make sure that it's sane, right? So Python is going to take this no problem. So next thing what we're going to do, I'm going to run a for loop. I don't need really any output of the for loop for underscore in range 20, right? And I'm going to call oops from there with no parameters in the parameter list, right? So what we would expect is that we call oops, we get an empty list that goes in, we add append one to an empty list, and then we just print it out, right? That sounds pretty reasonable, and we're just going to do it 20 times. So let's run it. I need to learn how to type, but other than that, it will be fine. All right, let's run it again. And we get this. We get this wonderful thing. And so this could occur with some frequency, especially with folks new to Python, where just kind of go through and muck things up real quick, and then you happen to assign a mutable value to a keyword argument as a default parameter, and then you happen to mutate that value internally. What had happened is that my list got declared as a variable as part of the function signature. So now every time you make a call, you essentially make a call against my list instance of a variable. As a result, each time my list is modified here, it literally tags on a single another one to this. So if you were to completely overwrite my list, right, it would not be a problem. But since we're modifying my list, what happens is that it literally runs in the loop, goes out, comes back into the same declared function, and appends another one to it. So you can imagine if you happen to do something like that in your code, that you might end up with what's called in our business memory leaks, right? And generally super weird behaviors that you could encounter. So you want to be cautious, as far as what you would assign to this. So normally what you would want to do in this case is let's declare a better let's create a better approach to this. So let's do this will trigger memory leak, right? And we're gonna comment this whole thing out, and then we're going to rewrite it with let's do def oops my list. So the workaround normally here is to default it to none, right? And then later we would go my list is equal to my list, what is it, or empty list, right? And then if we do my list append 1, and then we do print f my list here, in that instance, if we run this in a for loop, we're going to get a considerably better behavior. I mean, again, the example itself is contrived. Memory leaks like that are real, and it's not just memory leaks, but also a super odd behavior that you could end up with if you call the same function multiple times within your code base. You basically end up in instances where you start having weird values show up because they end up aggregating over time if you end up modifying this value. Definitely had happened to us in real life. Something to be careful of. So let's go into example of actually calling quarks and args together. So we're going to calling positional and key word arguments together. So we're going to define all together, and we're going to go with first arg just as a name, and then we're gonna call a bunch of positional args. Let's call it args plural. Then we're going to go sample quark. Again, names are arbitrary. We're gonna assign it to let's not assign it to anything, just to see what happens, and then we do star quarks, and then we're going to just do a massive printout of everything. Print let's do let's do first arg is going to be first arg. Then we're going to have args is going to be args. Then we're going to go for sample quark is going to be again sample quark, all the excitement, right? And then we're gonna print quarks as quarks. Sorry, squiggly brackets. Okay, so we get that. Run this just to make sure that everything is sane. I'm going to comment that out so that our printout doesn't look insane. And then let's just do all together. We're going to do 1, 2, 3, ABC. So sample quark. It doesn't really make much sense to do it this way. So let's assign it to an empty string. And so we do ABC, then we do sample quark equals to test me now, and then other sample equals to 1, 2, 3. Third one equals to I don't know, true, something like that. So if we run this, we see the breakdown of that. right? So again, we have, we pass in literally into 1 to 3. We have a first arg in there, so first arg is going to pick up 1 to 3. Then we have args. For the remainder of args, we get a tuple. So as a tuple, we can just get a first member of tuple, and we're just going to get pure ABC as a value, right? Then sample quark is our test me now string that we passed in here, so we just printed it out. And then remainder of quarks is other sample 1 to 3, third one is true, right? So it only picked up the ones that we did not account for explicitly in command line. So what happens there is that quarks in this case are actually a dictionary. So if you go quark square bracket other sample, is going to return just value 1 to 3 to you. Yeah, so that's the breakdown here of how they align. I'll let you guys finish typing a little bit. All right, creating and accessing optional positional parameters and keyword arguments. So yeah, so we honestly, now that I think about it, we literally just did that in here kind of as a breakdown. I should have a little bit more faith in my lesson plan. Anyways, so let's do passing quarks through without reusing them. So really, really cool kind of aspect for that is, and the reason for this to exist is you would have certain specialized libraries that would ride on top of more generic libraries. So imagine you would have, I don't know, some kind of logging library, for example, riding on top of a socket library, right? So what would happen there is that you would have a default socket connection, configured within your logging library, right? And so if you just call your logging library with like socket capability and give it an address, it's going to be able to connect and everything is going to be fine. Well, imagine a wrinkle is added to that is that now you need to use it in production, and you probably shouldn't be shipping stuff directly. You probably should be, using HTTPS, and you might have a receptor, catching it on a different port. Something maybe specialized to underlying socket library that you want to leverage that would not necessarily be exposed through your logging library, as an example, right? So what happens there's an opportunity for some of these calls in your logging library. Instead of wrapping this functionality and making sense of parameters, it would give you just an open keyword argument parameter, and you would basically would need to know at that point that you can pass parameters specialized to the underlying library to pick those up and get configured with special needs for you, and the library that rides above it doesn't need to know anything about that context. All it needs to do is pass those parameters in a quark form through without declaring each individual one that you can assign, right? So the entirety extent of parameters that could be passed to an underlying function could be passed through that star quark. So let's do that example here. So let's do def special call. I don't know, we're just calling it something, and we're gonna take parameter test1 equal, no, test, yeah, let's do test1 equals none, test2 equals 0, just so we have something. And then we're going to go and we're going to print, let's do f colon, the usual, so that we can format, and we're gonna say special call colon test1 is going to be, do that in parentheses so that it looks pretty. So it's going to be test 1, and then we're going to do test 2 is going to be test 2. So we have that as our secondary function. Let's just run it to make sure that it is sane and it works out. And then we're gonna do def our function that's gonna take in first one, second one, and quarks. Sorry, double star. So what we're going to do here, we are going to print we're going to print first one, we're going to print second one as second one, and then we are going to call special call, and we're going to pass quarks in. So the way you would pass quarks in into the function below, you would essentially roll up the entire dictionary of quarks into it. So the way you would do it is literally by doing the same thing as you see above again. So now let's run this to see that we have sanity check here. Wonderful. I'm going to print divider again above. Print divider again above. Let's do again our favorite 50, because why not? And then what we're going to do, we're going to make a call to our function, and we're going to pass 1, 2, 3 ABC, the usual. And then if we do nothing and just run it, we're going to get this output, right? So special call has test 1 equal to none, right? That's a default value, and test 2 equal to 0, right? Let's segment it a little bit. Let's put a positional parameter just because we can. So blah, let's go in here, right? And then when we call it, that blah is going to be 456, comma, and let's print blah just to kind of dress it up a little bit, give a little bit more context here. I'll slow down, let you guys finish typing. And I'm going to hit run, right? So we got, blah showing up, and here that's what we passed in. And so the rest of them became kind of default calls. Default quarks that are passed test is none, test 2 is 1. So what we could do here now, we can make a second call to our function, right? And we go again our 1, 2, 3, or 2, 4, 2, 4, 6, CDF, because why not? And then what we want to do, we want to set one of those parameters, test 2, to something special. Literally set it to something special, right? So we got that going for us. Let's run that and see what happens. So what happened here was that we passed this test 2 as something special, right? It got picked up here as quarks got passed through without our function being at all aware of what's being passed in, and then the underlying function picked up the test 2 parameter and assigned it and printed out here. So you could see where, like, if you need special configuration for underlying libraries and capability like that is dropped in, you would get this. This definitely has been heavily used in data staging uh, function in data staging libraries to where you create builders for your functions and you have fake values, for example, for all your attributes, and your builder doesn't need to be necessarily aware of underlying model, but you could pass in a value for a single item in the underlying model, and builder can pass it through, and that value is going to be assigned to what you need it to be. So something where you have this really open-ended kind of situation, or something where you have an underlying library that you want to tweak its capabilities to serve your special case and configuration, or what have you. So this is a rather common pattern. And also, generally, it's useful to understand what args and quarks are doing, because you will definitely see it in a rather large amount of libraries and decorators and things of that nature. All right, little breather, time check. We have 6 minutes. So we got unrolling dictionary into parameters and returning multiple values and unrolling them into a tuple. So let's hit those. I think they can be quick enough for us to tie it into the next 6 minutes. And then we're going to hit the rest of it probably next time, as we kind of tend to do with these things. All right, so let's do unrolling dictionaries. Let's see if we want to, let's not reuse anything. Let's just go with, so let's do define unroll me, and we're gonna do test, and we're gonna do, I don't know, support one, because I feel like naming things in silly way, equals to none, and then support 2 is equal to 0. And then we're gonna do print f. Let's see if I just copy all these things in here, because that's how we show how everything works. If only I could do copy paste. Okay, so let's do test. It's going to be test in squiggly brackets. Support 1 is going to be, come on, support 1 in squiggly brackets, and support 2 is going to be support 2 in squiggly brackets. So run that for sanity check. I made a mistake. It doesn't end with a colon. Definition supposed for a function supposed to end with a colon. The definition line. All right, so this ran, we're fine. And then we're gonna go, so what we're trying to do here, we're trying to evaluate support 1 and put values in support 1 and support 2. So what we're going, let's do this. So we're gonna define a list, or not list, a dictionary of arguments that we're gonna pass in. So we're going to have, let's call it my stuff, because why not? And we're going to declare it to be support. So it's going to be a string literal. Support 1 is going to be equal to test this, please. And support 2 is going to be true. And so what we're going to do, we're going to call unroll me. We're going to put 1, 2, 3 into test, and then we're going to put in star my stuff. And let's run it and see what happens. So what happened here was the keyword arguments, right? They are quarks within our world, and we are actually able to grab a dictionary where we index particular values with strings, right? So we provide key values for strings that correspond to parameters in the functions, and we are able to make this call here and enroll dictionary into keyword arguments so that then they get picked up as individuals in here. And so like all this manipulation going back and forth with these values are possible in various ways. So this is where you can create, we'll go into classes and do all those things, but this is where you can create a constructor with bunch of keyword arguments in it, and then you can initialize your classes with dictionaries and do things of that nature too, where like the flexibility and interoperability of this thing becomes actually quite fantastic. Obviously it's flexible, therefore error prone, therefore everything else. So this is where your test coverage comes in, and this is where that helps. And we're going to leave unrolling tuples to the next time. You probably would guess at this point how to do that, but we're going to do it next time. Right now we're at the edge of the hour, so I'm going to roll up this session, and we're going to complete functions next time and play around with a bunch of stuff and see how the lesson goes and if we can start on the next topic. So thank you for now, and we will see you next week. Have a good one. Bye.